So hello, I am Tirvesh. You are watching Tech Mania World of Knowledge. Today in this class, let us discuss what is a K-map or how do we work on K-map more further and some rules and regulations called as map rolling, overlapping and redundant. Before starting my class, let us revise what is this K-map actually. So a K-map means it is a graphical display of a fundamental product. So what is this fundamental product? Whatever the outputs we get, that is known as a K-map. So we can draw a K-map for two possibilities. One is sum of product and other one is product of sum. Okay. So to draw a K-map, we use a formula called as 2 to the power of n. Means n is number of inputs. I can call that as a number of inputs. So whenever you have a two variable called as x and y, then this is two variable K-map. Whenever you have three variables as x, y, z, it is a three variable K-map. Okay, when you have four variables w, x, y, z, means this is called as a four variable K-map. Okay, so there are three types of K-map which can be drawn. That is two variable, three variable, and four variable. So in a K-map, when we provide this formula 2 to the power of n means 2 to the power of 2, which is equals to 4. So whenever you have 4, then you are going to draw 4 boxes where input is given over this side and a numbering is done over here. Okay, this is like 0 and 1, 0 and 1, x bar, x, y bar, y. So this is the two variable K-map which we are going to draw. So three variable K-map means which you should have 8 boxes. So 8 boxes means it is like this. So this is the three variable K-map. Four variable means which you are going to see over here. This has 16 boxes where inputs is given here and the numberings were done. Numberings are like 0, 0, 0, 1, 1 bar and 1, 0 like this. So whenever we are going to work on K-map, we are going to map them. So the main advantages of this K-map is we can understand a result solution as easy, or I may say that it is very punctual as it possible. So we are not going to get a difficult solution, or I may also say that a confusion solutions. So whenever we do this K-map, we come across with a proper equivalent solution. So for that reason we use a K-map. So a K-map is a congruent map or it is a congruent map or a table map, also you can say that. So K-map, here the word is mapping are there, right? So how do we do a mapping? A mapping is done in three concepts. So one is pair, quad and octet. So first what you should do, you should check for octal. So in my previous video I had this one thing. Octal is not like this. Octal must have 8 bits. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8. So whenever you have 8 bits, then this is considered as an octal. So in last video I have explained that when you have 4 bits, then this is octal, but not that is not octal. Whenever you have 8 bits of numbers in a map, then it is called as an octal. So means when output is being combined or merged with 8 bits in a straight line or straight forward, like it may be like 1 1 1 1 like this. Okay, when a result comes like this, right? So this is a octal. Clear? This is a octal. What we call this an octal. Whenever you have 4 bits like this, then this is known as a quad. When you are having some numbers like this, when an adjacent variable is being merged like this, then it is a pair. Okay. So remember one thing. First, always you should check for octal. If octal is not there, then you should come for quad. After that, if quad is not there, then only you should map for pair. Clear? So the first step, you always must have first step before starting this mapping. They provide with some numbers like sigma of 1, 2, 3, 5, 7, 11, 13 and 15. If they give like this, you should number that to the particular values or particular placeholders. After numbering the particular placeholders, if you are working for SOP means it will be in sigma, so your output will be 1. If you are working for POS, it will be in a pi, then output will be 0. So after filling that, you should always fill the remaining blanks with zeros. Then you should start working for K-map. So this is the revised concept which we done in the previous classes. So today in this class, let us learn what is this mapping or other true rules. Not only that if you pair them, your work is finished. Not that. Whenever you should get a proper resultant or proper solution, always you should have three more concepts called as map rolling, overlapping and redundant. Overlapping, map rolling, overlapping, redundant. So let us see what is this map rolling, overlapping and redundant. Okay. So let us see what is map rolling, overlapping and redundant. So a map rolling. Consider a K-map. Okay, of four inputs, like 4 inputs means 2 to the power of 4. Consider a K-map of 4 inputs. So 2 to the power of 4 means which is equals to 16. Okay. So I'm going to number them like A, B. Name the variables as CD. This is the my variables. So I'm going to number them 0, 0, 0, 0, 0, 1, 1, 1 and 1, 0. Again 0, 0, 0, 1, 1, 1 and 1, 0. So let me name them also. Let me finish the outside work first. So A bar, B bar, A bar, B, A, B, A, B, A, B bar. Again, let me number them. A bar, sorry, C bar, D bar, C bar, D, C, D, C, D bar. Okay. So now, what is the map rolling? After you finish all the things, set of things. Say for example, some corners consist of ones. Okay. Or some corners consist of one. When you fold them, so take for example, I may take this paper. Consider this paper as a K-map. So when I fold this paper over here, this edges touches each other, right? So edges touches each other. That means that this paper may continue. That continuation is called as a map rolling. So when you have a input, say for example, you have an input called as 1, 1, 1, 1 here. So what happens here? This is the right corner, touches left corner, touches to right corner. Okay, left corner touches to right corner. Or I may say this one. Top will touch to bottom. This kinds of thing is called as a corner mapping or a map rolling. Or you may have a batch. Say for example a batch. Okay. So continuation, like this is a quad, right? So you can also continue as a quad. This is also a mapping. So remember one thing, whenever you do a mapping or a map rolling, this means that a continuation of the K-map is known as map rolling. Okay, but whenever you do a K-map, this should have only once in your K-map. At that time, this will be satisfied. So this is the rolling. Rolling in the textbook they have said as, consider a map. If its left edge touches the right edge and top edge touches the bottom edge, this is known as K-map or a special property of a congruent. So what does it say? This left edge will be touched to right edge or a top edge will be touched to bottom edge. So that type of congruence is known as a map rolling. So remember, whenever you are going to do a truth table says only single value. But whenever we do a K-map, it will be make it much easier. Truth table makes the things complex, but the K-map makes the things simpler or easier. Clear? So this is the map rolling. So map rolling means consider a K-map or which says that it is also known as a rolling map or rolling a paper. You remember rolling a paper itself. So what does the paper do? When you roll a paper, it touches the left edge and right edge. Correct? So same way, when you roll this map, left corner touches the right corner, top corner touches the bottom corner. This type of data are called as a map rolling. Okay? So now, what is the overlapping? So consider you have some variables over here. You have already mapped them. Okay? Consider you have a variable and you have already mapped them. But at some point of data instance, we can also make a variable near to touching that. So this thing or overlapping one after the other. This is known as overlapping a k-map. Means more than once. If a placeholder is mapped again and again in the same map, that kind of concepts are known as overlapping. Map rolling means area or edges touches each other and provides the continuous flow of data. That kinds of data are called as map rolling. But one or more data which is being merged again and again. Say for the example here, here you can observe here. Starting it is been quad, right? Quad we have considered, we have drawn a quad over here. But again, what I did, I had some numbers and I just used the same number to map one more variable. This kinds of instance is known as overlapping. Understood? So map rolling also, I hope you understood map rolling and overlapping also. I think you have understood. So last concept here is redundant. What is this redundant? A redundant is also known as duplication. So redundant means we also call them a duplication. What does the duplication say? Say for the example. Okay, say for the example. I may take again change them, drop that and redraw them again. So once I have mapped the number, okay. Again I will draw one more thing. Again I have drawn. This is paired, okay. Here two numbers are paired, okay. But there is an instance where again some persons will like to pair them also. But this is a duplication. Why? Because we have already used this in a pair. So if you remove that, your instance will be easier. This kinds of data instance or this kinds of entity is known as redundant. So this is a redundant. So you should always follow these rules when you are doing a k-map. So what is you have understood what is a k-map? A k-map is a graphical display of products in a truth table or a fundamental products of truth table. So when you are doing a k-map, you can draw a k-map or you can justify a k-map for SOP also and POF also or POS also. So whenever you are going to do SOP, you can understand when a question starts with sigma. These kinds of things are known as SOP. Here our output will be 1 and we are going to neglect a plus a bar because it is anyhow it is equals to 1. And when you are naming them, you are going to give a small letter. But when you are going to POF, you can identify the POF as pi means POS. Here output will be 0. You are forgetting a into a bar and your letter will be capital. So this is the main concept which you should know. Next, what you should do? Next, you should always have to draw a k-map. They ask to reduce the expression. They will ask you to reduce the expression. Reduce the expression using the k-map. So whenever you are going to reduce the expression, they will give some value as w, x, y, z. So you should check how many inputs are there. If you have 4 inputs, then it is 2 to the power of n, which is equals to 2 to the power of 4, and which is equals to, you should draw 16 boxes. Next, your thing is sigma. You should understand which type of reduction I should do. Whether it is SOP format or it is a POF. So when you have SOP format, then you provide the number, some numbers. What you should do for this number, you should put 1, rest all you should put zeros. So first that is the main step. Next, what you should do, you should map them. So whenever we are going to map, we have three concepts. One is octal. Next is quad. Other one is pair. So you should first you should check whether you have a octal configuration or you have a quad configuration or a pair configuration. So first always the preference will be octal. When a number is given in a such a format, then these kinds of data are known as octal. When numbers are given in such kind of format, these kinds of data are called as a quad. When numbers are given in this format, then it is known as a pair. Okay. So if you have together numbers, then you can also map like this also. This is called as a quad. Clear. So after this, map rolling. So you should always find a map rolling in any one of the concepts. So you should work on map rolling also. So when you have a corner pieces or in a top and bottom, when you have a corner pieces, say for the example, when you have a corner pieces, so when you have a corner pieces, say for the example, you have like numbers like this. So what you should do, you should quad them. When you doesn't have any numbers over here, only then what you should do, if you have one single one over here, you are going to pair them. Multiple ones means it is quad. Clear? So when you have 4 ones over here sidewise, then you are going to roll for octal. So always remember, whether you are doing a K-map or whether you are working on a map rolling, first preference you should give for octal. If octal is there, you should always mark them. Otherwise, you should not mark. You should not do that. If octal is not there, next comes the quad. You can't go directly for pairing. First octal, then quad, then it is pairing. So this is the explanation for map rolling, redundant, and overlapping. So now let us work on one sum, two sums, so you can understand much better. Clear? So now I am going to work on a sum called as. So I am going to work on a sum called as f of x, y, z, which is equals to sigma of 0, 2, 4, 5, 6. 0, 2, 4, 5, 6. So what is your work now? K-map is equals to 2 to the power of n. How many inputs are there? 1, 2, 3. Which is equals to 2 to the power of 3. Which is equals to 2 into 2 into 2. Which is equals to 2 to the power of 3 means. So 2 to the 4 to the 8. So what you should do? You should have your map, K-map, which consists of 8 unique boxes. What you should have? You should have a K-map which consists of 8 unique boxes. Observe carefully and understand properly. So now, what you should do? X, Y, Z means first part X, Y, Z. I have named. Now let me number them. 0, 1. 0, 0, 0, 1, 1, 1, 1, 0. Name them X bar and X. Y bar, Z bar, Y bar, Z, Y, Z, Y, Z bar. Okay. Now, what you should do? Now, you should also number the placeholders, right? 0, 1, 2, 3, 4, 5, 6 and 7. You should map them right now. What you should next step you should number them, right? Wherever the number you have, 0 means you should put 1. Here 2 means you should put 1. Here 4. 4 means 1 and 6 means also you should have 1 and 5. Right? 5 means you should put 1. 0, 2, 4 and 5. So next, what you should do? Next, we should second step is map rolling. So consider check for the octal. You doesn't have octal. Next, what you should do? You check for the pair. You doesn't have a pair also now. You have or no required. You doesn't have a quad, but you have a pair, right? So first, after before doing that, you should check in a map rolling also. So when you have map rolling, so look at here, left part touches the right part. So this is quad 1, Q1. Okay. Now that is the one. Now what you should have? You should only one side you should pair, right? Next what you should do? You should have a pair also. So now directly one pair I have. I'm not going to do much. So this is pair 1. Okay. Now what I should do? Next I should have a I should write how many pairs are there, how many parts are there. So there are one quad and one pair. So which is quad, which is pair I should also write. Now quad 1. Quad 1 means what is a quad? Where do I have one? Now quad where have a quad, right? So where do you have one? In 0 means I should write M0. 2 means I should write M2. Next 4 means I should write M4. Next 6 means I should write M6. Next pair 1. So pair means where I have M4 and M5. Okay. Next what I should do? I should write my reduced expression. So whenever I do a reduced expression, remember one thing, in SOP I should forget x plus x bar or vice versa. So reduced expression means what I should do? I should remove a changing variable from uncomplemented to complement. I should remove changing variable from uncomplemented to complement. So now let us see quad M4 and M0, M2, M4 and M6. So let me take M0, x plus x bar, I should cancel them. Now next what I should do? I should check for here y bar, z bar and yz. So y bar, z bar here, y plus y bar is gone. So what is remaining here? Quad 1 which is equal z bar. Means here how does it come? You just check out. Okay. Now wherever you have one x bar yz. Okay. X bar y bar z bar. X bar y bar z bar plus x bar y bar z bar plus x y bar z bar. So when you remove that, what do you get now? Now this x and x bar is gone, right? So y bar z bar plus y bar z, right? So x y z, right? So first one, always you should check this with this and this with here. So x bar y bar z bar plus x bar y z bar, x bar y z bar, x bar y z bar plus x y bar z bar plus x y z bar. Okay. Now what you should do? You should all remove them, right? Now here let me take first one this one. Okay. So now what does it happen? X bar y bar z bar plus x y z. So what is removed here? These things are removed because x plus x bar is 1. So what do we remember here? Z bar. Okay, so y, because I have taken all the common outs here, y bar y which is 1, here this is also equals to 1. What is remaining out here? Here z bar is remaining. Again here you see, here you observe, again what is remaining here? Z bar is remaining over here. So at last, what is your complement will be? It will be your Z bar. So to follow this step, it is very difficult. So what you should do? You should here itself you should do a mind calculation. So whenever you do a mind calculation, it means that here x bar and x, it is removed and it is 1. Next, what you should do? This line you have yz, okay, y bar and z bar, and this line you have yz bar. So again complemented to uncomplemented means y bar plus y, which is equals to 1. So quad means quad is equals to z bar. Understood? So next pair. So now let us pair now. X here. One having y bar and z bar, right? It is combined with y bar and z bar and y bar z, right? So what is the complemented symbol here? Z, right? Z bar and z. So it is remain. So what is remaining pair? Pair is equals to x. Pair is equals to x into y bar. So final expression. So what is your final expression? You should write them together. So z plus x into y bar. This is the final expression. So here what is the main contribution? See, first you check for octal. You doesn't have octal. Again what you did? You again check for map rolling. Whether when you do a map rolling you will get octal. Octal you had octal. You remove that. Next what you did? You just check for quad. So you check for quad in a normal mapping. It doesn't have a quad, but what you did, you just check for whole mapping, sorry, map rolling. So map rolling, you had a quad, you mark them. Again, you had a pair and you mark them. So this is what you finished with naming them. How many pairs are there? How many quads are there? You finished with naming, and what you did, you reduced that expression. So when you reduce the expression, what you should remember? One thing you should remember: x plus x bar is equals to 1. So I should neglect them. So after removing that, you should check for here whatever the symbols are there. If the complemented, if you should change that complemented to uncomplemented sign, you should remove that changes of complemented to uncomplemented sign. After that, the remaining data you should write them. Same way in pair also you should write the remaining data. So this is the 3 variable case. So let us one more thing, one more sum. Let us solve one more sum together. So you will understand it easier, more easy, more clearly. So now let me take 4 variables. Okay. So now let me take 4 variables here. So whenever the examiner asks the question, so how does the question be? F of, reduce the expression A, B, C, D, okay, which is equals to sigma of 0, 0, 2, 4, 8, 9, 10, 11, 12 and 13. 11, 12 and 13. Okay. So now what is your work? You should draw a K-map box. So what you should do? 2 to the power of n, which is equals to how many inputs are there? 4 inputs. So 2 to the power of 4, which is equals to 2 into 2 into 2 into 2, is equals to 16. So what you should do? You should draw a K-map which consists of 16 boxes. Should draw a K-map which consists of 16 boxes. So what you should do? In a left corner you should write the data. So A, B, C, D. So all the data has the placeholders, right? So you should write the placeholders, right? 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. So representation number, the representation number of the box, like 0, 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13, 14, 14 and 15. And name, right? A bar, B bar, A bar, B, A, B, A, B bar, C bar, D bar, C bar, D, C, D, C bar, C, D bar. Okay. Now, what is your work? Now you should check for the numbers. So wherever you have the numbers, you should put 1 there. Rest all you should finish with 0. So 0 you have number, 1 you have no number, 2 you have number, next 4 you have number, next 8 you have number, next 9 you have number, 11 also you have number, and 10 also you have number. Right? Next 12 you have number, and 13 you have number. Right? So this much you have a numbers. Rest all what you should do, rest all you should finish with zeros. Complete them with the zeros. So I will complete them with the zeros. Okay. So rest all I finished with zeros. Clear? So next what you should do? You should check for octal first. Did you find an octal anywhere? So here we doesn't have an octal. Again in a reverse map, means map rolling also doesn't have octal. So what you should do? You should check for quad. So you have a first quad. You found a first quad over here. Okay. Second quad. Again you found a second quad. So this, let me name them Q1. Second quad. Again you found a second quad also. So over here. Same. So what you should do? You should name them as Q2. Third quad, observe anywhere you found the third quad. So even you have found the third quad also. So over here. Right? Third quad. So observe this one has been overlapped several times. One or more times, right? Third quad. Okay, this is Q3. You should name them also, right? So let me name them also. So this is Q3. Fourth quad, anywhere you find the fourth quad? Roll the map now. So fourth quad also I observed right here. Check out here. 1, 2, 3 and 4. So this is the corner map. So this is Q4. So now what I should do? I should write how many quads are there, right? Now I doesn't require to see for pairing because I finished my mapping in quads. So what I should do? I should write them. There are 4 quads. So there are 4 quads. So there are 4 quads. Which are those now I should write, right? Q1. Where do we number Q1? So 0, 4, 12 and 8. So what is this? M0, M4, M12, M8. Quad 2. So which is that 8, 9, 11 and 8, 9, 10 and 11. So M8, M9, M10, M11. Quad 3, Q3 means 12, 13, 8, 9. M12, M13, M8, M9. Quad 4, which is quad 4 now. So 0, 2, 8, 10. So M0, M2, M0, M2, M0, M2, M8 and M10. So here you finish with quad 1, quad 4 quads. Now reduce the expression. So reduce the expression whenever you come with a single line. It means this is C bar D. These both are removed. A bar and completely is removed, right? Here a common, a common. Here a bar into a 0. So what is the this thing is been removed. So only we get with Q1 means C bar D bar. Q2 means again. Here this side is removed, only one part is there. So this part. So A B bar. Q3. So observe here. So here B bar and B is removed. So what is remaining? A. Next. Here. D bar and D is removed. What is remaining? C bar. C bar. Q4. So here A bar, B bar. Here. This one. So A bar, B bar, and this one. When you check what is remain, what is left out, what is same, B bar. So what you should do? B bar. Check out here. Next, this C bar, D bar, and this one. So what is C and C plus C bar is 1. So what is remaining? D bar. So final expression is, final expression. So final expression is C bar D bar plus A B bar plus A C bar plus B bar D bar. So this is the final expression. So hope you understood this concept. So in next class I am going to continue with same K-map, and after that let us finish this concept as early as possible. Thank you for your patience and thank you.